Hi, so going off of our previous videos, we've talked about production functions and cost curves. Now we're going to kind of take all of those together and work on problems. And hopefully that will give us a clear understanding of what these concepts are. So our example here, we have a production function. Here is our quantity is equal to 2L to the power of 1/2, K to the power of 1/2. It's a Cobb-Douglas, but doesn't really matter for this problem. We have our L and our K, where L is our labor and K is our capital, and we have our wage, which is W, is equal to 1, and rental rate of capital, which is 1. So it's just $1, $1. And then K dash, right? K and then dash on top is equal to 64. Basically means that K, that capital, is our constant, right? So whenever we see that, oh, it's constant, the capital is constant, then you can kind of assume that it is a short run problem, right? In the long run, capital can be anything, whatever it wants it to be, whatever the company wants it to be. And then, but in the short run, we keep our capital constant. Okay, so the question's asking, find our fixed cost, right? Fixed cost is basically, again, the cost that is fixed, that you pay up front or whatever, it's fixed. And we know that our capital here is fixed, right? This is constant. So we have our 64, right? And multiply that by the 1, right? The K goes with the R. Now you're probably asking, wait, why? Do not forget that formula. Do not forget this formula, right? Right, we have our cost is equal to wage times labor, the amount of labor, which is really just, how much a person is getting paid per hour or whatever the unit is, plus our rental rate of capital times that capital, right? That times that quantity in capital. Do not forget this. So whenever we have our fixed cost, you're going to kind of look at that cost that is fixed, and we have 64 times that $1 because it costs $1 to make each capital. So that's $64. Average fixed cost, what you do here is you're just dividing it by the quantity that is produced, right? So average fixed cost, if you look back at my other videos, I talked about in a graph, right? As you keep increasing your product, keep increasing the quantity that you have, your fixed cost is kind of going to get distributed, right? So if, let's say, a pizza costs $10, right, and you're distributing it amongst 2, where now here 2 is our quantity, that's $5 each, okay? And then, yeah, so $5 each. And then now if you're saying $10, but then you're distributing it amongst 10 people, that's $1 each. Keeps going, decreasing and decreasing as you increase the output. As you increase the quantity. So all you're doing here, whenever it asks average fixed cost, you're just dividing it by the quantity. And here the quantity is not known, so you're just going to do 64 divided by quantity. Variable cost here, this one can get tricky, but everything else is pretty straightforward after that. Now what we're doing is we're looking at the W times L portion of it, right? For this problem, we need to know what the L is. We need to know what the labor function is, right? What we do here is basically, okay, we have our quantity is equal to 2 square root of L square root of K, right? Because that's the same thing. This 1/2 is the same thing as that. And then we know our K. Wait, we already know our K. That really helps us, right? We know it's 2 times 8, because square root of 64, times L, which square root of L, so that's 16 square root of L. Now we have our quantity in terms of our labor. Now what we want is a function where we have labor in terms of quantity, right? So we're going to manipulate this equation so that we have our L by itself and then quantity by itself, right? So we divide this by 16, right? Divide both sides by 16, and then we get Q over 16 is equal to square root of L. Take the square, square both sides so you can get, have L by itself, and then you're going to have Q over 16, the whole thing squared, is equal to L. That really helps us, right? Because that is our L. Now all you have to do is just multiply it by our wage, right? Because W times L, remember, don't forget this formula. So one thing to notice is that since we're working with cost curves and all these different formulas, it's important to memorize or understand this formula, because a lot of different things can come out of this little formula, right? We can figure out our cost, our variable cost, fixed cost, all the averages. We can figure out marginal cost and marginal revenue. So this cost is this function is very important. This formula is very important. So yeah, so when we know that, okay, we have $1 times q over 16 whole squared, it's just, q over 16 whole squared. And one thing I did is I kind of just did q squared over 256. I took the square root square and distributed it. So that is going to be our variable cost, right? So for the average variable cost, it's pretty easy, right? We worked on it with the average fixed cost, just divide it by the quantity, right? That's how you figure out averages in general. So all we did was q squared over 256 divided by q. That q cancels out, right? And we end up with q over 256. And now, can seem tricky, but all we're doing with marginal cost, right, is it's basically the change in your cost, right, for an additional unit of output, for an additional unit of production, or whatever you're using. So, right, it's a change that happens in cost for an additional quantity. So whenever you think of that change, right, you're going to have to use derivatives. You're going to have to figure out the slope. And that is why we're trying to take the change from the variable cost, right? The variable costs are the ones that are going to be changing. The fixed cost, we don't need to find the change, because they're not going to be changing. The fixed costs don't change. Average fixed cost does, but we're not worrying about that right now. Fixed cost, the change in fixed cost is going to be 0. So the derivative of fixed cost is just going to be 0. So we don't care about that. So yes, so you're just taking the derivative of our variable cost function. Go back to our variable cost, right? We have q squared over 256. That's why I kind of distributed it. Makes the derivative easier. Bring that 2 down, right? How to take derivatives. And then you simplify it. It'll be like 2q over 256, and you're going to end up getting q over 128. And so I think it's really magical how much power we have with just knowing our production function, our wage, our rental rate of capital, and the fact that this is a short-term problem. So it's pretty great. So thank you.